Hello everyone and welcome to We Meet at Digital Days. My name is Lisa Richter and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Advanced Solution Center, the solution to all special and unusual PCBs using the example of stretchable circuit boards. Our speaker is Jürgen Wolf. He will hold a presentation and will answer your questions. Before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentation. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. You will find the chat function in the control panel. This presentation will be about 30 minutes long. The chat questions will be answered in a Q&A session following the webinar. There are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all of your questions within this time, we will answer them via email afterwards. If you still have any other questions left, just mail us at exhibition@we-online.com. We will try to answer all of your questions promptly. At the end of the webinar, you'll be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve our event. You will receive the link to the presentation in the next few days. The recording will be available at our website soon. So now I will hand over to our speaker and I wish you an exciting presentation.
Okay, thank you, Lisa. I hope everyone can hear me now. And again, is everything okay? Okay. So warm welcome from my side and welcome to my presentation about the Advanced Solution Center, which we just recently set up for all of our customers. What do I want to show you today? Well, basically, I will give you a short introduction, what we actually think and mean with Advanced Solution Center. And I will give you some short insights into the first stage of the implementation of our Advanced Solution Center. We will have a short look into embedding of components. We want to show you what we do with technology partners. And the main topic today, we will talk about the stretchable printed circuit boards in the Advanced Solution Center. And in the end, we are going to sum up everything. So let's just dive into. But before, I will just give you a short introduction to my person. My name, as already said, is Jürgen Wolf. I'm the head of this newly created Advanced Solution Center. And therefore, I am responsible for all these technologies which we deal with. I'm supporting the sales for the embedding and these novel technologies, and I'm responsible further on for the qualification, planning, and the further development for the in-house technologies which are dealing with these different topics. I'm with Würth Elektronik since 2008, and my contact details are shown on the bottom left. So if you want to contact me after this presentation, feel free to contact me either by phone, by email, or whatever. Okay, so what is the Advanced Solution Center? So first of all, we are really technology oriented. So we want to look on your different technologies, what you want to do, and we want to find solutions how we can offer these technologies and these solutions to you. Therefore, we are rather customer oriented. So we want to always find a solution for you. And this is why we are solution oriented as well. Additionally, we had a small restructuring at the CBT, so Printed Circuit Board division of Würth Elektronik, with the R&D, and this Advanced Solution Center is the new development area for our R&D as well. So why did we choose to create such an Advanced Solution Center? Well, we want basically to offer each single board which you have. So even if this is a rather complex technological product, we will try to find a solution for it. This could be either that we talk to our technical project teams of our manufacturing sites, if they could realize it by maybe slight adjustments to their standard products. and see if they can put this into our German plants, even if it's not in our standard PCB portfolio. If we cannot manufacture it by ourselves, then we are going to look into our partner database and see if there is someone out there who can manufacture this PCB on our behalf. So we are going to manage the whole PCB manufacturing in our hands. And your advantages would be that you have fewer contacts for PCB specific questions. So you do not need to go to manufacturer A for technology 1 and to manufacturer B for technology 2. So basically you can have everything from us, and therefore you are more productive and you can concentrate on really what is important to you, and this is your end product, what you want to sell to your customers. The big advantage you will have, we as Würth Elektronik are very well known in the printed circuit board industry. We are there since 1970s, so we have a huge and enormous technological know-how of which you can benefit in that way, because we are looking on what is being doable. If it's doable, we will find a way how to create and how to manufacture these boards, either by us, as I said, or together with a well-known partner. And this is why we set up this Advanced Solution Center in 3 different stages. The first stage we called is more technology. The second stage would be more layout. And the third stage is more know-how. So what is behind these topics? More technology means that we are looking on our own technologies and how we can further improve. And we offer, as I already said, the stretchable printed circuit boards, which is not standard in the PCB industry. We are offering embedded components or boards with embedded components, which is not standard in the PCB industry. And we are looking that we can adapt the standard technologies in our fabs so that your complex boards could be manufactured with our own technologies. If this is not possible, as I already said, we are looking for third parties. Together with partners, we try to find technology solutions for your applications, for your needs. In the second stage, we want to offer layout services. This means that we start with just the simple layout service as it is to create PCB boards. But we want to add more benefit from it so that you can do analysis or simulations like thermal simulations, like power distribution network simulations, and so on. And even if it comes to layout adjustments, this is something we want to offer as well. Maybe your internal layout department is just full with work, but you need to change something rather quickly and you do not get a slot in your internal department. Well, then you could contact us and say, okay, I have a slight adjustment, maybe change a footprint or maybe change part of the layout with other components or whatever it is, change the overall dimensions, the outline or whatever, then you could come to us and we would prepare these slight adjustments for you instead of waiting several weeks, maybe months till you get a planned slot in your layout department. And the third stage would be more know-how. We want to do more consulting or trainings when it comes to PCB related topics. And we even want to build up bookable online seminars, from very basic seminars, how is a PCB being built, up to very knowledgeable seminars when it comes to impedance control, high frequency boards and stuff like that. We want to even look into IPC related and UL related seminars, which can be booked then from the Advanced Solution Center. And the implementation, as I already said, would be in 3 stages. We already started with the first stage, so we have already cooperations going on when it comes to really high technologies, and I will show you later what I really mean with high technologies and advanced technologies. And we already started with the technology consulting part. The second stage will be implemented hopefully end this year. So in the 4th quarter, we want to start with the layout services. We already have a division in India who is offering this for the Indian market. And there are already around 20 experienced layouters there, which are offering this for the Indian market. And the Advanced Solution Center basically will then act as an European bridgehead or port of support, as you might want to call it. So that you even have a local contact person, and Yeah, we know this from the German market. Often it's easier to talk to a German guy about German problems. And this port of support, this bridgehead, well, he will translate this then and manage this with the Indian colleagues then. And the third stage, the more know-how should be implemented next year, where we are just building up a training program in all different kinds of forms when it comes to PCB related topics, from basics like how a PCB is built, really to up technology trainings. So let's have a look into the first stage, what we already do. Well, since quite some time, we are offering the possibility to embed components into the printed circuit board. And we gathered this together now into the Advanced Solution Center as well. So we are offering basically 3 different technologies, how components can be embedded into the printed circuit board. So the first one you see here in the middle, this is our so-called solder embedding technology, because here we take SMD components and we solder them directly onto inner layer cores, and these inner layer cores are being embedded then into the whole lamination. The components are completely surrounded and filled, or the cavities surrounding the components are completely filled with resins, so that there is a void-free build-up and all the components are securely embedded in the printed circuit board. The second technology which we can offer is the so-called micro-via embedding. Here we take bare dies, silicon or wide bandgap components, for example, dedicated passives, and we embed them into the printed circuit board and contact them by microvias. We will see later just a small example what the advantages is here. One thing I can say is that you can really get high reliabilities, maximum in miniaturization, because you're using the bare die, you're putting it into the board, and therefore have huge advantages. And the third technology is the so-called flip chip embedding technology, where we take bare dies, which are previously been bumped with gold bumps. We mount them in a flip chip process onto the inner layer core. This flip chip process is based on an anisotropic conductive adhesive process, so-called ACA, so that the component is directly mounted and connected in the flip chip process. This is something we do in pieces of 100,000s, for example, for RFID applications, customer-specific RFID tags, because I would say 95% of the RFID dies you get out there on the market are already pre-bumped, because this is the standard technology which is being used for standard RFID inlays as well. And therefore we implemented this process and adopted it to the PCB manufacturing as well. The reason why customers of ours are doing this is basically, on the one hand, it's miniaturization. As I said, you can get very small. You could even create your own package. So you do not have to rely on mold packages and mold forms. You can just use FR4 technology and PCB technology to create your own module, your own package. Or you can save space on outer layer assembly area. For example, if you have a second or third generation of your product and you do not know where to place your components anymore on the outer layers, you can take parts of the components, for example, and put them onto a second or third layer, which is inside of the PCB, so that you can make it either smaller or you can implement just more functionality into the same space. Then you can have this big topic of performance or function. We can create with these build-ups an integrated shielding, with the copper being involved in the PCB manufacturing. So you can create planes above and below the components. You can drill holes surrounding them, so you can put the components in a complete Faraday cage, for example. You can have very short signal paths so that the components can get very close together, even in a 3-dimensional way. For example, you can place decaps directly below your active component and not go to the side or to the back side of the board. And you can have a good protection against plagiarism, because on the first hand, it's hard to see that there are components inside. Even if you're doing X-ray pictures, it's hard to identify that the component is inside the board, not outside. Yeah, for sure. If you go very deeply inside, if you do computer tomography pictures, or if you slice it piece by piece, then you will find everything which is being inside. But you have a first implementation of protection against plagiarism. So the rework, the re-engineering is not that easy anymore. The third part basically is the reliability. So you can, by embedding the components into the epoxy resins of the printed circuit board materials, you can protect those components from environmental influences. So we have some applications which are running, for example, in the oil of the gearbox of cars. You can really secure and securely fix those components because the resin completely surrounds the components and fixes them inside the board. And what is really, really interesting is the thermal management. With our microwire embedding technology, for example, we can contact those components or these bare dies directly with copper. So there would be no other material in between. You have a direct copper connection between the component and the outer world. And therefore, this is really a very good heat path because the heat gets directly from the component into the copper, and you can structure this copper as you wish. You can transport the heat to the side or to the back side very easily. So let's have a look on these layer stacks. So here's some examples from the manufacturing. On the left top side, you see gallium nitride MOSFET, which is being embedded into a 4-layer board and contacted from front and back side. On the right side, you see a solution with a rigid flex. So we can combine this with all the other PCB technologies like microwire technology, like rigid flex technology. On the bottom side, this is an RFID application where you just have one copper layer, so it's not a part of the miniaturization. Here it's more the fact that this RFID die is being secured due to the mechanics needed, due to the environmental influences, so that it's not being destroyed in the application. It's really completely secured by the epoxy. Then we have just a standard built-up with HDI, and what even is possible that you add several layers of assembly, like you see on the bottom right picture, that you have more components inside. And this is where it gets tricky. You really have to plan in a 3-dimensional way where your component sits, where your signals flow. And this is where it's getting really interesting for new products and new applications which are have been previously not been able to realize. So you can think out of the box and see if there is any new solution which can be created with this kind of technology. Which version do you want to use or should you use? Well, basically, this is being decided by your application and the components you want to use, and you have to ask yourself several questions. So in which form are these components available? If these are SMD components, yeah, then you can solder them onto the inner layers. If we have bare dies, which have been previously, for example, wire bonded, and you can get them with, for example, a copper metallization, well, you can take them now and embed them with the microwire connections. And if this is our bare dies, which you have gold bumps, for example, then you choose the flip chip embedding. And often the question you have to ask yourself, or maybe your manufacturer or the supplier for your components, is in which form do you get these components? And then the next question is, if you have different component versions, the question is always, can I mix the technologies? For example, if I have an active component which just can be used in a flip chip process, can I add this to the other components which can be used for the solder embedding process? Basically, yes, it can be done, but it's not advisable, basically, because these are different assembly processes, and this mixing of technologies adds to cost. But if it's for the application, and if the application cannot be done otherwise, then for sure, yes, we can think about mixing of the technologies. The aim is always to have the best solution for the application in the end. So how does it actually look like? So we can have a look into just one or two examples. Here you see an example of a gallium nitride, a wide bandgap semiconductor being embedded into the printed circuit board. This is a 4-layer build-up, and you see the micro-sectioning picture where we have microwires contacting this gun die from front and from back side, so that you have source, gate, and drain contacted directly with copper. The back side, you see those microwire arrays, and in that case, these are used for the heat path and the power path, so that the heat can get out from the die directly to the backside, and you have a very good performance here. And you see this performance when we look on the simulated and measured junction temperature and compare this with a built up with a standard package based or assembled on a ceramic board. And you see that the performance basically is comparable. And this has been shown and presented at the PCIM last year or 2019. So if you're interested in this, you can have a look on this paper. There is just very much investigations being done here in that paper. So this is a really interesting thing. And we've seen here that we could even increase the performance by just increasing the number of microwires contacting the backside of the die. And this is something where we look at during the application, how many contacts do you really need from the backside? Because yeah, as always, the more contacts, the more costly it will be. So we will have to find a trade-off between performance and cost. So again, we have to look on what is needed later in the field. Another example, and then we will switch to the next topic, is one with the soldered components. In that case, it's a medical application, which you actually could buy from a microchip. It's a module which creates a complete radio solution for implants based on the medical communication service. And you see the history basically. On the left side, you see a standard system in package built up, where everything is being assembled on the top side of the board and the bottom side is being assembled onto the implant. And by good planning and by taking this bare die, which you see in the SIP on the left side in the middle, and embedding it into the module, the size could be shrinked really in that case to 70% or 30%, so that you have 70% savings. So this is really a huge figure. And here you see the concept, how it's actually been done, and the microsection here. So you see this bare die has been soldered directly on the interlayer core. You see the solder bumps and the bare die, and all the remaining passives like inductors and so on have been assembled on the top side, so that this is a very small, miniature, and highly effective module in that case. So let's have a look into the second part when it comes to technologies from third parties. Well, we have very close collaboration already with our technical project teams, so that we see what can be done in our fabs above the standard technologies. Or if it's not possible, then yeah, we're working together with technology partners to see and to find a solution for the issues and for the boards which we want to manufacture. Especially when it comes to these cooperation partners, we want to offer technologies like we cannot do at the moment in our own plant. So this would be, for example, very high layer count multi-layers, up to 60 layers, for example. And any layer HDI build-ups with staggered and stacked microwires. But then we want to go into these heavy copper build-ups, for example, with inner layer copper up to 210 micrometer or even 400 micrometer, depends if you want to have UL registration or not. Then we are looking on build-ups with copper bus bars inside the PCB, or copper inlays, or copper coins, as you want to call it. Then we want to have a look on these high frequency build-ups and microwave circuits together with our partners. And we want to come down in structure sizes. I wrote here 50 micron line space. Just yesterday, I had a product with 35 micron line space, and even for this, we can offer now a solution. So it's going down in sizes. We have more materials, more possibilities when we work together and with partners, so that these opportunities and these options are getting just more and more. And this is something we want to build up in future just much more. Again, just two short examples. Here you see one where we have a 1 millimeter thick copper profile embedded in the PCB. And in that case, it's even being contacted with copper-filled microwires. So this is an application, yeah, for an automotive headlamp, that you have a high power LED array sitting on top of the PCB, and the power can be distributed to the side and the back side with this copper profile. The second structure I want to show you is a custom designed flip chip BGA. Basically, you could already call this an IC substrate. So it's a 4-layer any layer with 50 micron light space on each layer with stacked and filled microwires. And this is something we are producing at the moment together with our technology partner as well. So you see there are quite a lot of new opportunities which you can get in future from Würth Elektronik printed circuit boards. And the last insight and the main part today I want to show you is the stretchable printed circuit boards. This is a really new and interesting technology. We just recently introduced this end of last year by offering it to our customers. And we started with all the webinars and doing the technology presentation. And the concept basically is rather simple. You take just a new substrate material based on polyurethane. It's a thermoplastic polyurethane, and we take this as a substrate material. Unfortunately, as I said, it's rather simple, but for the manufacturing, it wasn't that simple at all, because polyurethane, as you might know, is flexible and stretchable, and to handle something stretchable and flexible in our manufacturing actually wasn't that easy. So how do you get the stretchability? Because you might know copper itself is not stretchable at all. So we needed to find ways together with partners and had to look into qualifications. How can you get copper stretchable? And the easy result is you have to form special tracks. You can either create layouts with meander forms. There are several possibilities how copper tracks can be layouted so that they will have stretchability to a specific point. Our overall aim was always to use standard manufacturing processes. So we are doing this in our standard PCB fab. This is not a new fab. We set up everything so that we even can handle these boards in our standard fab. And the overall aim was to just give new possibilities, because this material, as it being stretchable, offers just a whole of lot new possibilities. You can have it as a stretchable piece when it comes, for example, when you laminate it onto textiles, so that you have the same stretchability basically as the textile itself, but you do not need to handle, I would say, any conductive yarn or conductive textiles. You just take a PCB, you can have the same layout systems as for PCB technology, and you still can combine this with those textile build-ups by laminating this stretchable PCBs onto the textiles. But you can go even to three-dimensional build-ups like a conformable electronics. When you do a thermoforming or deep drawing of these boards, if you combine them, for example, with PC plastics and so on. A big advantage is that you can assemble those PCBs for sure, otherwise it wouldn't be PCBs. The only drawback is that since you can laminate it to textiles, and since it's being polyurethane, which has a melting point of about 170 degrees, you unfortunately cannot use a standard solder process. So your well-known lead-free assembly process with 250, 260 degrees Celsius doesn't work here, unfortunately. So you have to rely on new solder paste, and for example, here in this case, a solder paste which has a very low melting point of around 140 degrees Celsius, so that the actual printed circuit board doesn't melt away. Your advantages, well, as I already said, you can have this dynamic stretchability of 5 to 20%, depending on your copper layout. You have a wide property profile of polyurethane. For example, it's biocompatible. You can use this in a lot of medical applications, even as catheters for implants or whatever. It's a very adaptable material, so it's very soft, and it's even more flexible than what you know from our polyimide flexible boards. So you have hardly any internal stress or stiffness in this material at all. It's very limp. And you can do multiple rotations and multiple crumplings or whatever without any influence on the stability and the electrical performance of these boards. But as I already said, it sounds easy to use a new material and to go into a completely new field in this stretch technology. But we had to learn that you have to do new reliability assessments, for example, as well. And since this is stretchable, the first point which we knew we would have to do is have a look on how stretchable it is really. So we had to do a cycling of the stretchability and see what happens if we really stretch the boards with a specific layout to a specific elongation. So we produced like hundreds of different dedicated samples. We constructed a cycling machine where we could do this stretching, and we wanted to measure during this cycling. And you see a short video here, basically, where you see for a 6% elongation, in that case, a meandered structure. We call this a horseshoe meander, and you directly see that we stretch it, release it, stretch it, and we always measure at the maximum and the minimum elongation points and see how is the resistivity of the copper track changing during lifetime cycling. And we do this up until we have a crack in the copper track, and then we analyze it and see how many cycles could we get, what was the failure mode, and so on. The material properties itself, well, we created a data sheet. So if you're interested in this technology, you can order the data sheet from us. But as I already said, it's a very skin-friendly material. It's biocompatible. It has a softening range of around 150 degrees and a little bit above, so that you can laminate it to different surfaces. And you have really new options how you can further process it. And the fields of applications where we are already doing prototypes and investigations with customers is a lot in the medical technology. This is where it's getting very interesting, but it's interesting for sensor technologies as well, for smart textiles, for soft robotics, Internet of Things, and of course for wearables as well. If you're interested in these technologies, you can have samples from us. So this is a picture, not a real picture. It's from the three-dimensional ECAD system. This is a sample which you can use. There are different meander forms on it. You can measure it, you can crumble it, you can wash it if you even want to, and see what happens with this sample. So to give you just an insight what can be done with this new technology, I have an example here which is already in series production. So this is our first series product, which has been fully qualified in this medical field here. This is a belt being used for newborns and premature babies, where you basically do an electrical impedance tomography of the chest area of this small baby. And why has this technology been chosen for this application? Well, because of this softness and because of the almost no stiffness, this limpness of the polyurethane. So the effect you get for this belt, this baby, well, it has already enough to struggle with this new world which it's already in. So you do not want to bother this baby with another thing like these other cables and wires and so on top. So we and the customer from us, the company Centec, tried to find a solution to make this belt very, very soft. And the solution was to use this polyurethane PCBs to get it stretchable and to get it very soft, so that these babies do have a little bit more comfort as they used to have with those previous belts, which were rather stiff and which were not very well accepted by these babies. So to sum everything up, so in future, and we already started with the first stage, we can offer to you basically PCB solutions for even very complex and technological products. So we want to basically find a solution for every one of your needs. We are checking if we can do this by ourselves, or if not possible, then we want to work together with partners. But the management of the PCBs and your contact is always for Würth Elektronik, so you do not have to deal with these partners. You can focus basically on your field, on your productivity, because you have fewer contacts. You have just maybe us or someone else, and not 5, 6, or 10 different PCB manufacturers. So you can concentrate what is important for you, what is essential for you, for your application, and you definitely benefit from our huge knowledge, because we try to find the solution for you in the future. So that's about it from my side today. I would like to thank you for joining this small webinar, and I think we can move on to the Q&A.
Thank you very much, Jürgen, for your interesting presentation. like you already said, we turn now our attention to your questions. So you've got now the chance to add your question in the chat window, and then we can see your questions. Okay, so let's have a look. Maybe we start with the first question. Can the stretchable PCBs be washed?
And this is something which we are at the moment actually investigating. So we are doing washing tests together at the moment with the Textile Institute. There are even norms how to do this. You have to have normed machines, normed chemistries, and so on. And this is going on at the moment. So our aim is to have for sure several washing cycles which survives or which our stretchable boards survive. So this is going on at the moment. And the aim is to have this solution so that they can be washed, because you want to add it into textiles, and then it would be very interesting to have them washed several times.
Okay. There's also a question for the stretch flex. Do you have any vibration test results?
No, we didn't do vibration test results. So we are still doing those stretchability cyclings, but not yet vibration test results. So not with components being assembled. So this is not being done yet.
Okay. Also a question, is it possible to get the stretchable PCBs with more than 2 layers?
At the moment, not. What we are working on is that we want to create in the future a combination of stretchable and rigid boards like you have for rigid flex PCBs. We want to create something like a stretch rigid or rigid stretch PCB, as you might want to call it in future. And in the rigid part, we want to have the possibility to have more than just 2 layers. But at the moment, the solutions we can offer with this stretchable material is just 2 layers. And this is something in development. So we are starting with 2 layers now, and more layers will come in future.
Okay. Also here's someone interested in the cost course. He's asking, why is embedding always so expensive?
Well, I get this question quite a lot, and this mostly comes when you have a point of view from a standard PCB option. So a standard PCB, if you compare this with a PCB with embedded component, there is a huge difference because you already have components inside. But if you think it from a different side, when you look on the assembly process, which can be shifted maybe from the outside to the inside, and if you look on the component cost and compare the whole system, then it's not much more expensive. Even if you have a new product or if you design it very well, you can even get to a point that you're on the same cost or even in less cost when you save space, for example, because it's always a factor of space on a production panel. So if the module is getting smaller, you get more modules on a production panel, and therefore you could even save cost. So it's something which has to be looked on a little bit differently compared to a standard PCB.
Okay, great. So there are still some questions left, but we have to finish now the presentation course to the time. So if there are any questions left, we will answer them via email afterwards. Thank you very much for your attention, and I hope you enjoyed our presentation. The next presentation topic is We Back Up Your Application, Hot Swappable Supercapacitor Backup Solution. The presentation starts at 4, and hopefully see you there and enjoy our digital days. So goodbye.
Goodbye and thank you.